Hello. In this video, I'm going to derive the solution to this problem involving a braking car. So the idea is you have a car, it's got a wheelbase B, its center of mass is height h center of mass above the ground, and a distance x center of mass behind the front wheels. So we can draw our center of mass right there. Okay. The first question says basically what we're doing is we have it's braking, and it is accelerating in the opposite direction, meaning accelerating backward because it's braking at acceleration a naught. Basically what we want to know what is the normal force on the front wheels. Okay, so to do this, I'm going to need to do the sum of torques. You can do the sum of torques about any point. I'm going to do the sum of torques about the center of mass. You could choose, if you're in your solution, you could choose to do sum of torques about other points, but I'm going to do the sum of torques about the center of mass. Okay, so for the sum of torques about the center of mass, we have we have basically there are two torques about the center of mass. There's the torque due to the front wheel and the torque due to the back wheel. So the torque due to the front wheel is this direction, so it's positive, and it will be force of front. I'll call force front for F sub F. That'll be the normal force. Force front. That'll be the normal force up on the front wheels, and it will have a lever arm of X center of mass. On the back wheels, we will have a force of our torque of minus, because it'll be in the opposite direction, and it'll have a torque of force back. That's the normal force on the back wheels, force back there, times a lever arm of B minus X center mass. Finally, there's one more torque, and that is the torque due to friction. So we have a frictional force backward like this. So that is torquing in this direction, which is the negative direction. So we have minus force. Actually, I'm going to rename this. I'm going to rename the front force normal front, force normal back. We'll call this one normal front, normal back, because I need force of friction, force of F to be force of friction, and that will be have a lever arm of H center of mass, right? Because the center of mass is here, the frictional force is down here, and so it torques in this direction. It doesn't matter whether the friction is on the front wheel or the back wheel, because they're on the same line. Basically have the same lever arm of H center of mass. Okay, so that's all the torques. The net torque on the car is going to be 0, assuming it's not going to flip over, right? It's not going to turn. It's slowing down, but it's not going to turn. So that's the total torque. So that's an H, not a K. Okay, so that's the sum of torques. What variables do we know? Which variables do we not know? So we don't know the normal force on the front. We don't know the normal force on the back. We do know the frictional force. Force friction is equal to the mass of the car times a naught. That's in magnitude. Its force friction is m a naught. Okay, so we know that one. We can plug that in there. We can plug that one in there, but we don't know the front and the back. So we have two unknowns. We can find those using the fact that the total force up and down better be 0. So now let's add the sum of forces. So this comes in the free body diagram. We have two normal forces, force normal front, force normal back, and mg, capital mg. So we have force normal front plus force normal back minus mg equals 0. Once again, two unknowns. So basically we have two equations and two unknowns. Now it's just up to us to find the normal force on the front wheels. And then question 2 will be the normal force on the back wheels. And then we'll go on to part 3 after that. Okay, so let's find, basically we have two equations, two unknowns. We're going to eliminate one of our variables. We want to find front force, the normal force on the front wheels first. So let's eliminate the back. So I'm going to solve this for back and then plug it into the first one. So force normal back is equal to mg minus force normal front. I then plug that in there, and I get a big long whooping equation of nfx center of mass minus mg minus force normal front b minus x center of mass minus ma0 h center mass equals 0. Okay, so now we're down to one unknown, f normal front. We just need to solve for it. Okay, so pull it out. So force normal front x center mass plus force normal front times b minus x center mass is equal to mg times b minus x center mass plus m a0 h center mass. Okay, so we got all of our normal forces on this side, the other terms on that side. We now can do some division. Force normal front is equal to, I should use the same m here for both mg and ma. It's the same mass. It's a capital M, M. So we have mg b minus x center mass plus m a0 h center of mass all over x center of mass plus b minus x center of mass. Oh, that's convenient. Those cancel, and we're left with b there. We can simplify this a bit more and write force normal front is equal to m out front times g b minus x center mass plus a naught h center of mass over b. Okay, and that is the normal force on the front of the car. So that's the force on the front wheels. Presumably that would be distributed 50-50, you know, half of that on each of the two front wheels, but I'm not going to worry about this. This is the total on the two front wheels. Okay. So now let's find the normal force on the back wheels. So we can use this equation right here. The sum of the force on the back wheel is mg minus force normal front. So part 2, we have force normal back is equal to mg minus force normal front. We'll plug that in. Zoom up on it. Force normal back is equal to mg times or minus this big thing here, mg b minus x, the center of mass, plus a0h center of mass over b. Okay, if we want to combine these fractions, we have to multiply this guy top and bottom by b. We then pull it in here, it'll be bmg, but that'll exactly cancel this term. So we can rewrite this as force normal back, we'll absorb the minus sign, is equal to mg, or actually I want to write the m out front like I did earlier, so it'll be equal to m x center of mass times g minus a not h center of mass all over b. So I just canceled this term with that term here, and then took this minus sign in, distributed to those two, and I got the normal force on the back wheels. You can check if you add these two together, you will get mg. Okay. Now let's do the final question. Let's go back to what it was. The final question asks us if the coefficient of static friction on the wheels is mu s. If you're worried about slipping, which wheel should you put more force on? Or basically, which set of wheels can supply the most braking force? This is relevant. Imagine, for example, you're putting snow tires on the winter, and you can either put snow tires on your front or on your back, because you only have two snow tires. Where do you, or you have two set of snow tires that are better than the other sets. You have two good snow tires and two bad snow tires. Where do you put your good ones? Do you put your good ones on the front or put your good ones on the back? Okay. So we want the most normal force, because your frictional force is proportional to your normal force. So the wheels that have the most normal force are the most important for braking. Okay, so which of these two will have the most frictional force for braking? Well, let's do this simple case where x center of mass equals 1/2 b. If we use that, then force normal front is equal to m g b minus 1/2 b is 1/2 b plus a naught h center of mass, while over b is a naught h center of mass, while the force, the normal force on the back wheels will equal the same thing almost, but g 1/2 b minus a naught h center of mass all over b. And obviously this one is, they're the same other than the plus and the minus, so the top one must be bigger, aka there is a bigger normal force on your front wheels. So when you're braking, if the center of mass is halfway between the front wheels and the back wheels, there will be a greater normal force on your front wheels. So your front wheels are more important for braking. More important. Okay, and that solves that problem.